Hello, everyone. Welcome to the classroom of Advanced Manufacturing Technologies for Welded Structures. Today, we will learn about CNC Edge Processing. I am the lecturer, Yu Sao Ron. First, let's get to know equipment and material preparation. 1. Inspection of equipment. 1. CNC machine status. Confirm normal spindle lubrication and sufficient rail lubricating oil. Check the tool magazine change action and clean the shank taper surface. 2. Tool selection. Chamfering tool. Select angle and blade length according to chamfer size. End mill. Use a 4-flute carbide end mill for fine edge trimming. Ball nose cutter. Use an R5 ball nose cutter for curved surface edge processing. 3. Clamp inspection. Fix the workpiece with a vise or vacuum chuck with a parallel pad height difference less than or equal to 0.02 millimeters. Ensure uniform clamping force. 2. Material handling. 1. Blank inspection. Measure the original dimensions of workpiece. Length or width or height tolerance plus or minus 0.5 millimeters. And confirm the edge allowance, single side 1 to 3 millimeters. Clean burrs and oxide layers, treated with a wire brush until surface roughness are a less than or equal to 6.3 micrometers. Next, let's learn about programming and parameter setting. 1. Processing path programming. 1. Model import. Import the CAD model into software. 2. Path planning. Chamfering. Set tool compensation with a cutting depth of 0.5 to 1 millimeter per pass. Contour trimming. Follow a climb milling strategy, leaving a 0.1 millimeters finish allowance. Surface milling. Generate contour paths with a step distance less than or equal to 0.2 millimeters. R5 ball nose cutter. 3. Post-processing. Generate G-code and add coolant commands. 2. Processing parameter setting. 1. Cutting parameters. 2. Coolant setting. Water-based cutting fluid concentration 8 to 10%. Flow rate greater than or equal to 10 liters per minute. Turn on internal cooling shank during finishing. Next is trial cutting and calibration. 1. Tool setting and workpiece coordinate system setup. 1. Tool setting gauge calibration. Select a contact tool setting gauge. Accuracy plus or minus 0.005 millimeters to set tool length compensation, H value. Set the origin of workpiece coordinate system at the edge reference corner. 2. Trial cutting verification. Run the program in dry run mode to check for tool path interference. Trial cut a 5 by 5 millimeters area and measure dimensional errors, plus or minus 0.02 millimeters for finishing. Next is formal processing. 1. Processing execution. 1. Roughing stage. Layered cutting with coolant flushing of chips. Monitor the cutting force. 2. Finishing stage. Reduce feed rate to 50% of roughing and enable constant linear speed control of spindle. Select spiral tool engagement for surface processing. 2. Process monitoring. 1. Exception handling. Tool edge chipping. Immediately stop the machine, replace the tool, and recalibrate tool compensation. Chip winding. Adjust the cutting fluid spray angle or increase the chip breaker groove parameters. Next, we will learn about post-processing and quality inspection. 1. Post-processing. 1. Deburring. Process sharp edges with a file or vibratory deburring machine. 2. Cleaning and rust prevention. Ultrasonic cleaning. 2. Quality inspection. 1. Dimensional detection. 2. Surface quality. Now let's understand the safety and maintenance of CNC edge processing. 1. Safety regulations. 1. Personal protection. Wear safety glasses and noise protection earmuffs. 2. Equipment safety. Do not open the protective door during processing. Reset all axes after triggering the emergency stop button. 2. Maintenance. 1. Daily maintenance. Clean chips daily and check the tightness of the rail chip scrapers. 2. Regular maintenance. Replace the spindle lubricating oil monthly and calibrate the grading ruler accuracy. CNC edge processing is explained with the edge milling for bevel groove processing as an example. Milling machine processing requirements. Positioning requirements. 1. For the pressure beam milling machines, the unified positioning part extension is 20 mm. For floor milling machines, take the position plate edge as the reference. 2. The theoretical reference value for the distance between stacked milling positioning parts is shown in the PPT. Before hoisting parts, ensure no iron chips are on the work table. If present, clean the work table thoroughly. Part clamping. 1. Pressure beam milling machines are equipped with split clamping or full clamping, with the pressure foot preferably in the middle of part. It is forbidden for one pressure foot to clamp two adjacent parts simultaneously. 2. Split clamping is suitable for floor milling machines, with the screw clamped between two parts. Note: set the air gun to position 3 or 4, and maintain air gun tightening for 3s after bolting. Selection of cutting speed and cutting volume. 1. The feed speed for pressure beam milling machines is generally 360 to 450 mm per minute. For 35 degrees bevel grooves on parts T22 or above, cutting must be completed in 2 passes as shown in Figure 1. 2. The feed speed for floor milling machines is generally 150 to 420 mm per minute. For 10 degrees bevel grooves with a cutting volume of 9 mm above, cutting must be completed in 2 passes, as shown in Figure 2. Bevel groove acceptance criteria. Tips. The inspection and determination of 10 degrees bevel grooves are shown in the PPT. For a 20 mm thick part requiring a 10 degrees bevel groove with a 22.5 degrees bevel height of 14, the processed hypotenuse with L equal to 5 times 6 is equal to 30 or 5.5 times 6 is equal to 33 meets process requirements. Surface quality requirements for bevel grooves. The part bevel surface shall be free of slag, burrs, notches, or other defects, with a surface roughness RA less than or equal to 12.5 micrometers. 100% full inspection is required. This lesson is concluded. Thank you for listening.